Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Hafiz bin Zulkifli with metric ID AE190016. So today I will present a simulation about experiment 8, a basic AC circuit. So I will present about activity 1 and 2. So firstly, I will go for the activity 1. So in the instruction given, the source of the AC voltage is given 10 volt with frequency 50. So as we all know, the load located in series mode, which is the resistance, and with series condition with the inductor. So for the first reading, I will put the value 210 ohm for resistance, and for inductance, I will put 0.4 Henry. So we proceed to the simulation. Here is the voltmeter and here is the ammeter. So it shows 28.869 milliampere, and for voltage is 7.071. So I already do for the oil reading for another variable of load. So this is the simulation value that I got from the simulation. So next we go for the activity 2, which is the same concept but different position of resistor and inductor. The load is in parallel condition. So initially I will put the value 210 ohm and 0.4 Henry. So we will run the simulation and read the ammeter and the voltmeter. So I assume that all the voltmeter here is all the same, because the how to read is VRMS, but for the ammeter is 65.419 milliampere. So for another reading for each of the load here, I have already done. So that's all for this experiment. Thank you.
Assalamualaikum, I am Muhammad Afiq bin Aharul Nisam. My metric number is AE190052 and I will explain about activity 3 and activity 4. So for activity 3, the series resistive capacitive load circuit. So for the first step is we have to complete the simulation circuit using the 390 ohm resistor to 2 microfarad capacitor, and we have a 10 voltage peak with 50 Hz frequency. For the second step is we have to measure the value of current and voltage using AC ammeter and AC voltmeter. I use the multimeter because it is easier to measure both of the value. I will show you the example of 390 ohm and 2 microfarad capacitor. So here we have the current through the circuit is 4.32 milliampere and the voltage is 7.071 volt. I have done the other simulation for 4 microfarad and 8 microfarad, also 210 ohm, 470 ohm and 860 ohm. The result I have record in the table, and then we have to compare the value of the calculation value and simulation value. So here we can see that the value of voltage is all the same, but the value of current is a bit different. It is because of the decimal that I take in the calculation value. So for activity 4, the parallel resistive and capacitive load circuit, for the first step is we have to complete the simulation circuit with input of 10 volt peak 50 Hz, and insert the value of resistor and capacitor in parallel as the load. So using ammeter and voltmeter, we have to measure and record the value of current and voltage in table respectively. We have to change the value of load according to the values given in the table 8.4 and record the result. So I am going to show you the simulation of the first one, 390 ohm and 2 microfarad capacitor. So we have here the value of the current is 18.67 milliampere. The value of voltage is 7.01 volt. For other value, I have done it, and this is the result. And we have to compare the simulation value from the multisim to the calculation value that I have done here. We got that the value of voltage and current is pretty similar of all the value. Thank you. That's all for activity 3 and 4.
Hi and Assalamualaikum. So next we will discuss about activity 5, which are the series RLC load circuits. So here are the circuits for the activity 5. We can see the RLC loads are in series arrangement for this activity. So we need to design in the software, simulation software. So the software that I use is the Proteus Professional, and here are the design for the circuit of activity 5. Here we have the V-signs, which consists of 50 VAC and 50 Hz of frequency. We have the ammeter, RLC load in series, and also the voltmeter. So first, we will run for the first parameter, which are 390 ohm plus 0.4 Henry and plus 2 microfarads. So here are the parameter. So we will run the simulation. So we get for both current and voltage. So the current is 23.6 milliampere, while the voltage is 35.3 volts. Next, we will run for the second parameter, which are 470 ohm plus 0.4 Henry plus 2 microfarad. So we need to change the resistor value to 470 ohm. So we can see here that there is a value for both voltage and current. So we can see here that the voltage is the same, which are 35.3, while the current is different from the previous parameter. And here are the full result for the simulation result, which are the right side of the table, which the value for the simulation value. Well, this left side is the value for calculation, the manual calculation, which we calculate from below. So we can see here that all 7 parameter which different combination of value have different value in currents but same value in the voltage. So that's all for activity 5. Thank you. Lastly, we will discuss about activity 6, which are the parallel RLC LED circuit. So these are the figure for the RLC LED circuit in the parallel arrangements. So the software that we will use is the multi-sim simulation software, and here are the design for the circuit for activity 6. So we have the BS, which are the AC source with 50 V peak, which are equivalent to 50 VAC, and also we have the 50 Hz of frequency. The XMM1 will act as ammeter. Next, we have the RLC in the parallel arrangement, and lastly, we have the XMM2, which will act as a voltmeter for this circuit. So we will run for the first parameter, which are 390 ohm, 0.4 Henry, and 2 microfarads. So here are the result for the first parameter. So the current we got is 273.611 milliampere, while the voltage is 35.355 volts. So this is for the first parameter. Next, we will run for the second parameter, which are 470 ohm, and the same inductor and capacitor is 0.4 Henry and 2 microfarad. So we will run the simulation, and here the result for the second parameter. So we can see here that the voltage are in the same value, but the current is a little bit different from the previous one. And this is the full result for the simulation value, which are on the right side of the table. So we can see here that all the value for the for all 7 parameter for the load R, L, and C. So we can see here that the voltage are the same in the simulation. We are 35.355. While for the current, we have a different value for each parameter. As for the calculation value, we will need to do the manual calculation, and the below here are the step by step for the manual calculation, and these are the result for the manual calculation value. So that's all for activity 6 and for our experiment 8. Thank you for watching.